Good morning, everybody. My name's Barry Evans from the University of Surrey Institute for Communication Systems, and I'll be chairing this panel session on satellites and non-terrestrial networks. We have a distinguished panel, Tomaso from DLR, who's also chair of the Network Europe SATCOM Working Group, Antonio Franchi, who's director of ESA's future programs, Kieran Arnold is the Director of Ubiquitous Connectivity from the Satellite Applications Catapult here in the UK, and Nicolas Chuberre, who's 5G Solutions Director from Thales Alenia Space and moderates the Satellite Systems IG group. So next slide. We will be having essentially 4 talks and then a Q&A session. But just to start things going, I thought I'd mention the roadmap. So from 2021 to 2025, we've essentially got 5G and moving into 5G plus, where we're starting to embed satellites into 5G and demonstration and trials will proceed. From, I guess, today, moving to 2030, we'll be entering the 6G world, where we'll start to develop technologies for satellites in a 6G environment, which we're scheduling for around 2030. So where are we today? We have early 5G satellite backhaul systems that have been trialed in 2019 and 20. In the standards organization, 3GPP, we have a very active NTN, Non-Terrestrial Networks group, and in release 17, standards work has started in NTN and will be completed by 2022. So we're likely to see the first commercial backhaul implementations maybe around 2024-25. The issue of direct-to-terminal systems using new radio will probably be the following step on from that. Work has started on looking at new markets for 6G, and I think we're going to hear a lot more about that in the panel session today. And I'd like to just pose a question which I hope will get answered by our speakers today. Will 6G be a truly integrated satellite terrestrial ecosystem? So that's my question to pose things off. And I propose we go now to the first talk, which is from Tomaso. So Tomaso, over to you.
Thank you, Barry. So I'm Tomaso from the German Aerospace Center. And I want to give a few notes on the horizon that is in front of us, I mean, in front of the non-terrestrial networks, in this journey that we have kind of just started from 5G to 6G. Next, please. So certainly in these initial days of this 6G symposium started 2 days ago, many talks have already addressed what 6G is or will be. Certainly so far there are a lot of thoughts, there is nothing really settled. Nevertheless, starting from what has been or is going to be very soon 5G, is important to put a vision what the 6G system might be. We have, of course, to take into account the different aspects, like the verticals, like consumer, industry, professional, and application that come with very diverse requirements. And on top of that, below that, of course, there are all the other elements that may be possible to implement such services, like the provisioning, the infrastructure, and the devices. All of this is possible by means of very specific enablers that are somehow based on the initial work that has been carried out in the context of 5G, like edge computing and storage, very diverse radio technologies, new spectrum bands like terahertz, softwareization, virtualization, and last but not the least, of course, artificial intelligence. In this large picture, of course, non-terrestrial network is expected to play an important role. Differently from what happened with the beginning of the 5G exploratory studies, something like 10 years ago, where satellite was not in the forefront of all the considered technologies. Nowadays, non-terrestrial networks, since I would say a couple of years, has become a key ingredient for the future of a telecommunication system, and therefore is going to be playing an important role in the evolution in the path from 5G to 6G. Next, please. In that respect, of course, it's important to develop a kind of vision of what will be the main ingredients of 6G and accordingly the services. We have already seen in the previous talks in these 2 previous days that, of course, as we already experienced in the previous Gs, there will be a continuous evolution and revolution, in fact, of what 6G may represent with respect to 5G, similar to what we witnessed in the past years in the promises that 5G is expected to meet in comparison to what 4G was already doing. And in this, as already reminded, there is the goal of making of deep use of machine learning and artificial intelligence concept, exploiting new frequency bands like terahertz and beyond. And of course, there are all these technology components and elements like full system softwareization by means of SDN and FV, multi-access edge computing, and ultimately there is the need for achieving unprecedented energy efficiency. New service, of course, will be enabled. Of course, 6G doesn't mean that all services will be forgotten. There will be the old, but new services with very extreme requirements, like in the case of holographic telepresence, eHealth with haptic applications, unmanned mobility, and so on. Next, please. And these requirements typically relate to latency, bandwidth, security, and energy efficiency. As already pointed out in the course of the study carried out within ITU as part of the focus group Network 2030, amongst the different components, an important role is going to be played by the so-called space terrestrial integrated networks, that often is recalled to as STIN, that in other words, is what we refer to in 3GPP and nowadays in different contexts as a non-terrestrial network. So that a non-terrestrial network is expected to be converged in the upcoming beyond 5G and therefore 6G deployments in order to meet some of these goals that definitely will be harder to be satisfied with just the terrestrial architecture. Next, please. Of course, if we take into consideration the overall picture of terrestrial networks or in general 5G, we can identify a number of areas that will see important contribution from the NTN part, like ubiquitous availability and infinite network capacity, that are kind of classical themes where satellite communication has been and will play an important role. And then, of course, there are other areas where the contribution of NTN will be fundamental, like throughput, ultra low end-to-end latency, security, energy efficiency, and last but not the least, we have the massive IoT service management, where NTN will be enabled, especially in relation to the trend of MB IoT that is currently ongoing in 3GPP. Next, please. From this standpoint, of course, we have to see exactly how to position non-terrestrial networks in the overall context of beyond 5G and 6G. In general, we have classical goals from NTN technologies, like guaranteeing ubiquitous coverage with limited infrastructure, take advantage of the inherent multicast functionalities, and eventually one of the most common trend nowadays is to achieve the so-called concept of connecting the unconnected. On top of that, of course, there are new frontiers like pushing the content to the edge in order to achieve the so-called quasi-zero latency perception. All of this, of course, might be further achieved by means of the renewed interest towards LEO satellites, LEO constellation, in light of their capability of providing further reduced latency, capability of onboard storage, edge computing capability, and so on. So that at the end, what we envision for the near future is to have a complex non-terrestrial network ecosystem tightly integrated in the rest of the network, where the rest of the network, of course, is the terrestrial one, where, however, there are other components that I'm going to depict a little bit further in the next slide. So here it's important to point out essentially how NTN could appear in the overall ecosystem. And the general idea that encompasses all possible system composing 6G will be to have the concept of a 3D system, 3D architecture, so that differently from the past, where essentially we have a kind of a 2D, or if you like, a flat architecture, mostly building on terrestrial components, we'll have space segments that will be integrated with the rest of the 2D infrastructure by means of GEO, MEO, LEO constellation, but also other aerial systems like high altitude platforms, aircraft, drones, and so on. Of course, in this very heterogeneous picture, it's very important to achieve seamless integration, and this will happen by means of the concepts that have already appeared in the course of 5G design, like network slicing, SDN, NFV, MAC principles, so multi-access edge computing. And all of this means to provide satellite systems with the functionalities that maybe in the past were considered just futuristic, whereas now is the time has finally come, like onboard caching, computation capability, and all of this, of course, will help achieve a full concept of data distribution network, where data are going to be distributed through all the nodes composing this very diverse network. Next. An important aspect that will be played is certainly the presence of optical links. That's why a possible question is to which extent optical links may represent the next big thing in non-terrestrial networks and in general in 6G. We know that geosatellite have played an important role because of their large coverage, but in general, providing very complete coverage along with very high capacity is not so easy. That's why the availability of optical feeder links that may provide very high data rate, exploitation of large spectrum is certainly an asset. This is not just theory or based on some papers, but is something that has been already ongoing since I would say roughly 10 years, especially in terms of at the beginning of theoretical speculation, and then more recently in terms of experimentation. Certainly we know of the example of intersatellite links building on free space optics. That is the reality, for instance, for new satellites from Starlink. There are other experimentation that has been done all over the world, and more interesting, there is the so-called Hydron platform from the European Space Agency, where we'll have a kind of a multi-tier satellite architecture that will be heavily based on optical links. And as such, we see optical communication as a key ingredient in the evolution of non-terrestrial network so as to enable new services in 6G. And then to conclude in the next slide, it's important therefore to remind the fact that 6G certainly is expected to further bring new revolutionary elements in comparison to what 5G already did with respect to 5G. All of this comes with new and in some cases more stringent QS and QE requirements The recent studies and results from trials and experimentation show that terrestrial alone probably won't be enough to meet all these current, but more importantly, new requirements. That's why the role of a non-terrestrial network will be very important. And in this sense, indeed, the fact of integrating non-terrestrial network with the terrestrial network is not just a business perspective, but it's really a need in order to provide new use cases and more importantly, to make a more efficient use of the current ones towards civil society and industry 4.0. So that at the very end, the vision is to have non-terrestrial networks and terrestrial networks very tightly integrated, as I'm writing here, in terms of living symbiotically interchangeably, like a software architecture where the different pieces can be interchanged in a seamless manner. And all of this, of course, will be of key importance in order to take advantage of the maturity of new technologies in the context of NTN, as just mentioned in the previous slide, that certainly will be further analyzed in the course of the upcoming releases of 3GPP, and more importantly, further sustained by means of the studies and the experimentation that are going to happen from now until, as showed in Barry's presentation, until 2025, in order to become reality with the 6G implementation from 2025 onwards. That's all from my side, and then I can give the floor to the next presenter.
Okay, thank you very much, Tomaso, for that, kicking us off with that vision as far as the satellite is concerned in 6G. Now I'd like to hand over to Antonio Franchi to actually give us a view from the European Space Agency. Antonio.
Thank you very much, Barry. Good day, everyone. I hope you're well and enjoying the symposium so far. I'm Antonio, and I'm with the European Space Agency in the UK office. Today I'm calling from sunny London in the UK. The title of my talk is ESA Space for 5G and 6G. This is the name of a recently new program that we have created at the European Space Agency in order to support industry, telecommunication industry, in particular the space sector industry, to capitalize on this massive opportunity that 5G and 6G offers to everyone. In fact, we believe strongly that 5G and 6G represent a triple win opportunity. Is first of all a great opportunity for the satellite telecommunication industry to join the terrestrial industry to provide this seamless, ubiquitous communication that 5G and 6G promises. So there is a great opportunity, perhaps more than for any other Gs, for the space sector to be an integral part of delivery of 5G and 6G. Secondly, is a win opportunity for the terrestrial industry that working alongside the satellite telecommunication industry, the mobile network operator can utilize space sector elements in their heterogeneous network to reach more customers. So it's a great opportunity for the terrestrial cellular industry. And finally, perhaps more importantly, is a great win opportunity for the society by and large. 5G and 6G promise ubiquitous, secure, seamless communications to serve industry 4.0 in a variety of use cases, and also to serve society as a whole and improve everyday life on Earth. Perhaps today more than ever, we see the importance of ubiquitous connectivity and things like telemedicine, telehealth, teleeducation, and other use cases, which I'll touch upon in my talk, becomes very essential to the well-being of humanity in general. And we believe that by the convergence of satellite and terrestrial telecommunication in the 5G and 6G era, we can help humanity to live a better life, connected and healthier. So moving to the next slide, of course, there is a very strong commercial drive behind these 5G and 6G opportunities. So I thought I just want to spend one slide to focus that besides the triple win opportunity, there is a strong commercial justification to invest in 5G and 6G. Reputable market research company estimate that the macroeconomic impact of 5G and 6G in the next 10 to 15 years up to 2035 is in the orders of $13 trillion. This is a massive, staggering amount of capital and money that is going to be enabled on a macroeconomic global impact from the ubiquitous connectivity of 5G and 6G. And of this potential large macroeconomic impact, the direct impact that satellite can bring is in the order of $500 billion. So satellite in itself cannot be neglected. In fact, it should be considered an integral part of creating the connectivity fabric, which will enable the economy of the future. Having said that, already from now, we see that mobile connectivity, at least terrestrially, is very, very widespread already with $1.1 trillion in 2019 from global mobile revenues and about 8 billion mobile cellular subscriptions. We see this trend obviously growing, and with the convergence and integration of satellite connectivity into terrestrial hybrid devices, the trend will grow. The impact of 5G enabled devices will become material from 2025, and even that just on this, we estimated just on the satellite mobile revenues, handheld devices, perhaps direct access to satellite itself represent a significant economic impact. So all in all, I think 5G and 6G enable an inclusive, sustainable, and competitive global economy. In order to achieve and materialize this high potential, the integration, the seamless convergence between satellite and terrestrial connectivity is instrumental to enable this commercial opportunity. So leaving economy aside for a while, if we move to the next slide, what I would like to focus is what the European Space Agency is doing in particular in supporting industry across a variety of range of actions to financially and technically, and perhaps also from a regulatory standpoint, support the 5G and 6G roadmap implementation. First and foremost, we are very, very active in supporting industry in the standardization bodies, as mentioned already before, and we'll have a estimate expert in standardization following here this panel with Nicolas Chuberre. We'll talk more about it, but space networks being part of the 3GPP standardization is condition sine qua non, is a necessary condition in order to make sure that this convergence is enabled. And since release 17, the convergence is happening. Satellite networks are part of the 3GPP standard and in a variety of different formats. Obviously, the integration from satellite and terrestrial 5G and 6G happens at different level of network architecture, service layer, network layer, air interface layer. So there are different ways for which satellite networks and terrestrial networks can and should integrate. First of all, from a service continuity, is the end-to-end service continuity can be achieved at application level. So different type of satellites can interoperate and integrate with different type of terrestrial networks in order to deliver a seamless service to the end users. But more importantly, we are supporting a number of what we call essential building blocks in the 5G to 6G roadmap in order to enable and develop new non-terrestrial network air interface, new non-terrestrial network core networks, and ground segment network, which are seamlessly integrated with 5G terrestrial and 6G terrestrial networks. We are supporting a number of satellite proof of concept missions in order to verify the 3D space net that Tomaso was mentioning in the previous talk, in order to enable and understand the best architectural trade-off to make sure the satellite becomes an effective, technological, feasible, and commercially viable integration with the terrestrial network. So both at core network level and air interface level and service level, we are funding development building blocks, integration building blocks, and verifying them with a program of over-the-air technology demonstration and service demonstrations of different level of architecture, whether it's backhaul, integrated access backhaul, direct access, or a variety of other combination. What we're trying to project in this slide effectively is that these building blocks help building a bridge, if you like, from the terrestrial 5G, 6G world, which is depicted on the bottom right with the set of terrestrial massive antennas, to the top left, which is the satellite world, and make sure that this convergence happens in a more seamless way where air interface, core network, service layer, edge computing, and ultimately the end user see as an homogeneous, integrated, seamless network. All of this is fully supported across a range of programmatic tools that we use at the European Space Agency, where terrestrial network technology providers, satellite technology developers, ground network, user terminal manufacturers can talk to us and benefit from the support, financial, technical, and regulatory support that we make available for the industry. So that's on the technology side. Perhaps if we move to the next slide, I would like to focus a little bit on the downstream and application side. Obviously, non-terrestrial network enables a number of application and vertical markets, as I mentioned before, both for industry, business-to-business applications, and also for society by and large. Here, I just want to mention that the range of applications and services that we support in the 5G to 6G service roadmap is pretty much following the 5G and 6G vertical use cases and vertical market defined by terrestrial colleagues, but perhaps focusing on those where attributes like ubiquity, coverage, security, resilience are more important. That's where satellite play a perhaps unique role in fulfilling those stringent requirements and attributes. Just going to the little icon from left to right, just mention some of the area where we are particularly involved in supporting industry. The role of digital health and telehealth and telemedicine is something that is very close to our heart, especially in these difficult times of the pandemic. And we see that the trends from hospital-centered care to distributed care and telemedicine and the distribution of healthcare globally will strongly rely on the connectivity, secure data platform where information can be securely shared between doctors and patients, for example, or local clinics and hospital. And that's where the connectivity fabric enabled by converged networks play a key role. Same can be said for tele-education, teleschooling, and the need to reach rural remote areas or difficult to reach areas for education. But other fundamental market sectors for 5G and 6G satellite integrated applications are, of course, the agri-tech and agriculture sector, which will benefit by the variety of distributed sensors in remote areas and fields, and precise agriculture techniques, which require continuous monitoring, IoT, and the distribution of devices across a wide geographic territory. The entire market of transport, whether it's aviation, unmanned air vehicles, drones, or the widespread and developing market of maritime autonomous ships, so autonomous transport, autonomous drones, autonomous ships, autonomous cars is obviously a very, very key focus that will continue to develop a great amount of technology and affect the global economy. Is something that satellite can definitely play a key role in 5G and 6G. Finally, the renewable energy and a special effect on global climate, and how can the combination of different space assets like Earth observation, navigation, monitoring the environment, and connectivity by satellite can help the reach of the Sustainable Development Goals, which 6G very much aspires to. So the entire range of application and services is well supported by the European Space Agency program, and we invite application service providers, solution developers, and integrators, different vertical market stakeholders to make use of the tools available and utilize space and the satellite telecommunication non-terrestrial networks as contributors to the network connectivity fabric required to deploy all this set of applications. So I hope this gives a quick overview both on the technology side and on the application side of the level of support that we provide in very much promoting non-terrestrial networks as embedded in everybody and everyday's life. So moving on to the next, please. This is just an example where I mention autonomy and transport and connectivity. Obviously, the connected autonomous vehicle ecosystem is booming and is becoming more and more important, not only driving the electrification of vehicles, electric vehicles, and the entire ecosystem related between vehicle to grid and the energy grid management, but also on the autonomy of the driving the car itself, the connectivity and the security required in order to trust systems, autonomous system, intelligence system, or machine learning system to drive the car by themselves, the control mechanism required to enable this level of connectivity and trust globally, and also the economic impact of new service business model which are enabled by this ubiquitous connectivity. For example, the driver of an electric car can actually provide and sell electricity to the grid in a moment when the car doesn't need it, the driver doesn't need it. So there's new business model and business platform, an entire new range of data, secure data platform, which are being developed, and those data platform require the security and connectivity that 5G and 6G satellite can help deliver in a reliable, resilient, and ubiquitous way. Moving on to the next. I just want to mention, since we are from the UK office, what we are doing at the European Space Agency, specifically here in the UK. We have established a new innovation hub, and it's a 5G, 6G innovation hub. And the idea is to have a collaborative place, not just another 5G testbed or hub, but this is a special hub where there is satellite and terrestrial interconnection, which will become almost an engineering lab where different solution and architecture can be tested, but perhaps more important, 5G and 6G demonstration and application can be trialed over our hybrid 5G, 6G networks, where a combination of satellites and terrestrial 5G networks is enabling the validation and verification of some use case, whether it's a deployment of a fast, rapidly deployable mobile private network connected by satellite, whether it's a backhaul, or whether it's a hybrid solution to test connected autonomous vehicle in a satellite terrestrial connectivity mode. This is what the hub is designed for, and aims at promoting, advertising, and making a resource available to the community, to the wider European community, UK and European community, to test their ideas, their application, and their new, perhaps technical and business models to verify in a safe, secure environment in our hub. Next slide, please. I'm sure you will have seen a lot of roadmaps in the previous couple of days, but this is our very high level, is a kind of visionary roadmap how we intend to support our European industry and help satellite to be part of the global 5G and 6G roadmap. We are now supporting development, integration, and test of a range of 5G and satellite integration systems. We will continue to support standardization in the next decade to make sure that satellites remain part of the family of standards, which we started with release 17. We will support technology and application in the next 5 to 10 years, which is so-called 5G and beyond, which is the intermediate step bridging 5G to 6G, in which we will see not only the follow-up of the 3GPP releases from perhaps 18 to 2021, but also a progressive convergence and progressive putting in place of those elements of the space 3D networks that the previous speaker was mentioning about. At the same time, of course, we're looking forward ahead and start being part of the 6G research enabling technologies study and initial demonstration, perhaps with development of some 6G digital twins, which will help us to better understand how space and terrestrial network can play an important part in the 6G definition and evolution. Of course, we support the 6G standards and eventually the 6G implementation, by which time we hope that satellite will become just one of the many networks within these 3D space networks, which are supported by the wider converged integrated 3GPP roadmap. I thought this is perhaps not completely new, but this is our view from space industry, European space industry, and how ESA can support the convergence of the telecom industry going forward. Next slide, please. And this is a call for opportunity. The program I mentioned is called Space for 5G and 6G. It's a strategic program across our telecommunication, ESA telecommunication directorate, supporting a range of development and application from initial study to technology development, application and services. The program has been subscribed by the majority of our member states, our 22 member states in Europe and Canada, including Canada. And currently, is a multi-hundreds of millions of euros available to industry to develop products, service, and application in helping roll out the 5G and 6G roadmap and the convergence with terrestrial networks. You can find more information on our website, or you can contact me at the email below in the bottom right, 5g@esa.int. And we'll be very happy to provide more information about the opportunity for European industry and Canadian industry. Next slide, please. Okay, this is my last slide. Just to summarize, this is our Space for 5G and 6G program. I hope relay the information on the left, which we want to support the digital economy, in particular the 5G, 6G economy, by improving everyday life, inspire future generation, and enable the industry of the future. My keyword I want to leave with you is on the right of the slide. The attributes like seamless connectivity, ubiquitous connectivity, resilient connectivity are attributes which call for satellite space networks to converge with terrestrial networks and help develop those significant attributes which will enable a variety of application and services and ultimately realize the staggering number that the 5G and 6G economy can and will deliver. Thank you very much for your attention. I really appreciate attention. I'll be very happy to answer questions with the rest of the panel, and I will pass back the floor to the chair. Thank you very much.
Thank you very much, Antonio, for that view from ESA. I'd like to move swiftly on to the next speaker, Kieran from Satellite Applications Catapult. Kieran?
Thank you, Barry, and thank you to the previous speakers as well for enlightening us on certainly what's happening in the industry at the moment. I'm Kieran Arnold. I'm the Director of Ubiquitous Connectivity. For those people who are not familiar with the Satellite Applications Catapult, we are a government-funded research and technology organisation based in Harwell and in Westcott. I'm actually talking to you from our Westcott site in Buckinghamshire, where we house our innovation centre and our 5G testbed as well. We're also lucky enough to have the OneWeb user ground terminals located here and are undertaking a series of technical integration experimentations with the LEO satellite constellation, our 5G network, as well as undertaking some European Space Agency projects and Horizon 2020. So just to follow on from Antonia's talk, I would actively encourage people to engage with ESA. Certainly the program that is being run is not just a technology and demonstration program. It funds some technical innovation in that area, as well as supporting standardization. And we'll hear about that from Nicolas later on and what's happening within that field of standardization with 3GPP. So next slide, please. For those of you a bit like me who've been in the industry a little while now, you'll have seen it change quite dramatically in the decades. Certainly, we continually see the telecoms industry going through iteration after iteration or release and release. And certainly since the inception of 3GPP in 1998, we've seen a huge change in the cellular network evolution and that cumulating now into 5G and what 5G will deliver. And I certainly see 5G and 6G as a whole new bedrock, a whole new grounding for technology. And certainly seeing things like virtualization, software-defined networking, machine learning and integrated AI with intelligent networks, being that mobile edge compute, with low latency connections. And actually what we're seeing now is the integration of networks. You know, it's nothing new what we're seeing in 3GPP. Trusted 3GPP networks such as Wi-Fi have been integrated for some time now. And what we're now seeing is the integration of non-terrestrial networks into the standardization and the connectivity family within 3GPP. So next slide, please. When we talk about non-terrestrial networks, the reason why we don't generally say satellite in general, because it encompasses a plethora of platforms, airborne platforms, not just necessarily satellites, but high altitude platforms, HAPS, airborne assets where a radio system is being propagated from that platform. But in general terms, we talk about satellite, and we'll talk about satellite in this context and where that's actually being used. So geostationary, medium Earth orbit satellites and low Earth orbit satellites as well. And the important bit to understand is the architecture of those satellites that are being used. They're either, as we lovingly refer to them, transparent bent pipe payload satellites or processed payload, e.g. regenerative, where some sort of change in modulation or coding scheme or some sort of processing will take on board that satellite. And in the future, we expect that certainly when we start looking at virtualization and software-defined networking, an element of that will take place as well on the satellite infrastructure and integrate into an end-to-end network. I've summarized some of the activities that are going on in 3GPP in the bottom of this slide. I don't intend to go through them in much technical detail, but I will summarize some of these in the following slides. I'm conscious that we have quite a lot to go through yet. So I'm going to focus in the next slide, please, on some of the areas of seamless mobility and handover, focus what's in TS22s, and also what are the challenges that we'll see and some of the scenarios we're looking across as well. So any integration at some point in time will include an element of handover or takeover. It's important that it's certainly with the satellite or NTN integrations, these perform the same handover takeover functionalities we see in radio access networks today in 3GPP, as well as also network reselection and moving from one network to another, and particularly the handover between non-terrestrial and terrestrial networks in the variety of orbits that we'll see within non-terrestrial networks. So in other words, the LEO, GEO, MEO integration as a hierarchy or heterogeneous set of networks, as well as a terrestrial-based network handover as well. So being able to roam seamlessly, be able to manage subscriber identity and security, and as well as the important part for most operators is understand billing and accounting mechanisms within those networks as well, while the end user sees a seamless service continuity and quality of service as he moves from one network, one radio access network to another. And it's important to understand when we start talking about the non-terrestrial networks, we are seeing this really as just another radio network that a UE, UT will connect to or be offered a connection to once authorized and move across those technologies dependent on the UE or UT capability. So next slide, please. If we focus on some of the scenarios, and I won't go into technical details, but certainly as we see the evolution of non-technical network architectures within the satellites, as they move from bent pipe and possibly to process payload or regenerative payload, we start to understand how 5G and possibly 6G functions will be embedded within those architectures. And in these ones, in scenarios 1 to 3 here, we talk about a generic 5G architecture and what the network functions and virtualization functions will be and where they could be anchored within a network. And there are architectural advantages to do that. That might be due to latency considerations or the reduction of control plane across multiple networks, and the complexity of having control plane passing from multiple networks, or user plane being locally dispersed or anchored or dropped off at certain points in the network. So in these scenarios, we're seeing, particularly here, which we point out, the UPF either being in the ground segment, in the satellite, or a mix of satellite systems offering both control plane and user plane where the UPF is in there. That could be as simple as a terrestrial network controlling a network function or a network function from a terrestrial network embedded within an NTN network and providing capability to the end user or the UT. E.g., UE is selecting which UPF is being offered to it. That could be a terrestrial network UPF within the satellite NTN network, or that could be the UPF of the NTN operator on behalf of a terrestrial network operator. And then finally, in scenario 3, when we start importantly looking at seamless mobility, when you start talking about MEC and seamless service across separate MNOs, in other words, a MEC application being anchored in one domain and being moved across into another domain, then the satellite providing that bridge or capability for the MP3 interface provides that roaming capability. In fact, within that scenario, we see the satellite or NTN network providing a proxy function for the MP3 interface, where we can guarantee service continuity or application consistency across one MEC server to another. So last slide, please. Rather controversial this, it's not the view of 3GPP, it's really me looking forward at 6G, and certainly this slide was produced 2 to 3 years ago, is where are we heading, or what's happening now within 5G, and how do we see intelligent edge nodes, e.g. radio access nodes, with capability built in to manage macro mobility across a series of cells. So moving away, I think, from the traditional core network where control plane functions are embedded in the control network in the core, where these now will move to the edge, and actually the core being an element of nothing more than something like a cybersecurity agent, a identity agent, and also billing, etc. And we will probably see, and certainly be interesting to see how or what AI and machine learning, ML, will provide within the intelligent reselection or the movement of the UT or UE and end user applications in the future at the edge of the network, as opposed to what we see today, where we have RAN and core networks still playing a considerable part in an architectural future, certainly within 5G. And obviously virtualization and software-defined networking being part of that story going forward. So just to conclude, I think there are some huge technical challenges to still become over. There are standardization that needs to be set in stone, certainly between release 17 and 18, and as we go forward with NTN, we need to understand the scenarios, and certainly we need to understand the technical evolution of NTN to be able to support network virtualization, software-defined networking, and those types of technologies which we take for granted in 5G today. So I'm going to conclude there and hand over to Nicolas, and thank you for the opportunity to speak today. Thank you.
Thank you very much, Kieran. Can we swiftly then move over to our final speaker, Nicolas Chuberre from Thales Alenia Space. Nicolas, over to you.
Thank you, Barry, and hello, everybody. So I'd like to share a vision from an industry representative of satellite in 6G. Next slide, please. So I just wanted to recall about what are the main relevant satellite system concept that we are targeting in 5G. And I would distinguish them between the type of orbit, the targeted user equipment, and along with the antenna they have, whether they're omnidirectional or directional, type of services that are pursued and the type of application. So this table is trying to capture that. And obviously, the challenges associated to each of these scenarios are going to be different, both from economic and technical and regulatory perspective. So if we are looking at below 6 gigahertz systems, we can see that there are two kind of possible systems. The one that are targeting low-end IoT devices, where obviously the cost of devices is very, very small, but the narrowband is what is needed. Whereas if we there could be another kind of infrastructure with constellation with more satellite, but targeting a smartphone, commercial smartphone, and providing wideband. So we're not talking about the 5G high broadband, but we're more talking about wideband. And we see that a real commercial interest, because the coverage is a key market differentiator for mobile network operators, especially in countries where the terrestrial network is relatively limited in terms of percentage of territory. In there, the challenge is to achieve for few dollars per gigabytes delivery cost. So it is a big challenge, but the space industry has done so much in terms of innovation at the launcher, as well as the space technology on board, that we believe that now it's something that we can achieve, whereas 5 or 10 years ago it was not possible. And then if you're looking into the above 10 gigahertz kind of system concept, where they're GEO or NGS or targeting VSAT or eSIM. So this kind of terminal mounted on some moving platforms, whether aeronautic moving platforms, vessels, even larger drones, but also trains and so on. they can really deliver broadband kind of services, and they can address a large application range. And then you have the geo only targeting broadcast. So these are the kind of satellite concept that we are considering. These concepts are basically very similar to the one before, but the intent is to achieve a full integration in 5G and then beyond. And so the only one which is really disruptive is to be able to address commercial smartphones directly from satellite. All the others system concepts are existing already, and they have demonstrated commercially viability. Next slide, please. Yeah, so here we are in 3GPP. We have 3 ongoing work items at different level, SA2, round 2 for the NR, and round 1, there is a study which may convert to, potentially is going to convert to a work item for narrowband AUT and EMTC protocol to support satellite. So this effort resulted from what was done over the 4 years and highly supported by ESA via, for instance, the ALIX project, but other projects as well. And in parallel to this standardization effort, there are some development ongoing. So here are just example of some demos that have been done. So you can have a look at that, and not talking about ambitious industrial initiatives that are currently leveraging this standardization effort, especially initiatives related to the direct access, so targeting smartphones. Next slide, please. Yeah, well, why 6G? I think we have, you all know about the story of the mobile system, so I will not go very deeply in that. NGMN produced recently a very good document to explain what could be the positioning of 6G compared to 5G. So I just would like to point that white paper out. I would just point one thing is environmental sustainability is probably an increasing concern in the society, and that we have to take that into account in 6G. And that's why I would say that 6G should provide more with less resources at all levels. Next slide, please. Yeah, the vision for 6G that I'd like to share is very similar to the one that was presented by Tomaso from DLR. So it's a multi-layered integrated architecture. So I would like more to put emphasis on the terms of unification. So no distinguish between terrestrial and non-terrestrial elements. And for this, I'd like to go to the next slide, please. Yeah, so this picture tries to explain what happened 4G, 5G, and 6G, and probably will help some people who are trying to understand what's happening in the satellite industry. So in the 4G, you had basically 2 separate industries working separately on their solutions and trying to interoperate their systems via network protocol interface at IP layer or above even, but very separate. In 5G, what we have to try to achieve, and we are working very closely with cellular industry, is to see how we can reuse the terrestrial protocols and technologies, and with minimum impact to adopt them into the satellite systems. And in order to achieve this integration and deliver this vision of extended coverage, additional reliability, and so on. So truly providing some new service opportunity that would benefit from a combined and integrated satellite and cellular, because the users, and especially vertical users, are calling for this integration. Before, they were having devices that were very separate between SATCOM capabilities and terrestrial, and they want to achieve this integration, and they want to achieve this roaming between the two systems. And we're talking about traditional verticals that are interested in global service continuity, which are mainly transport area, security area, agriculture, and so on. So this is what we are currently doing in 6GPP and developing in parallel solutions to meet their requirements. And in 6G, we believe that it will be possible to consider a design and a common framework that would be optimized for both components against a set of common goals. So here we are talking about truly unification from day start, from the start of the deployment. Next slide, please. Yeah, so what is going to be the main contribution to 6G? Well, the same as 5G, coverage, and resiliency of the network. It can contribute to extend the coverage of mobile network operators and contribute to improve the resiliency of the network. These are the main added value. So we clearly see that the satellite is not something which is going to replace the cellular network. That would be ridiculous, but it's something which is very supplementary and complementary. And the contribution to the 6G ambitions as set by the NGMN are related to the support of the economical development in unserved and underserved areas, and also probably to contribute to the overall energy efficiency. And the service benefits is related to the resiliency, but also I would like to point out the possibility to improve the accuracy and the reliability of the positioning. That's something very also important. And the third thing is, we believe that it's going to help the reliability and cost efficiency in especially uncertain, underserved areas. So we think there is a true benefits of combining both kind of a component as part of this 6G technology framework. Next slide, please. So here is a list of technology enablers. Probably I'm not going to go through each one by one, but I would say that the integration is going to take place at the deepest level, and I would say that the lowest, the deepest integration will deliver most service opportunity and business opportunity for the general telecom ecosystem for the benefits of the users. So combination of positioning methods, combination of access, unified radio resource management, spectrum sharing, multi-service waveform, and so on. These are kind of technology we should investigate, between experts from cellular and satellite. Next slide, please. So as a conclusion, I see that 6G will certain leverage on the 5G technology framework and add new features and capabilities. And we can say that thanks to the ongoing effort, we see satellite as already part of the 3GPP roadmap. We believe that for 6G, we should try to have a deployment aligned in terms of satellite network component with respect to the terrestrial network. And R&D on the satellite component for 6G should start, yeah, very timely, 2022, once the release 17 will be completed. So that would be my recommendation. Now, I've seen a lot of questions that were shared, and I don't know how I don't know if I can answer one that was.
Can we go to Q&A, Nicolas? Thank you very much. Maybe, okay. And I'll try and pick up the questions from the Q&A now. So, thank you, Nicolas. Thank you, all of the participants. I can see also there's a lot of questions in the Q&A, and perhaps I can give the floor to some of the participants here. One or two questions that are very similar. There is one question from Igor. I've lost it again here, sorry. Let me go back. Igor Josic. Igor, if you would like to raise this question, or I can read it out, but it's preferable perhaps you raise the question. Igor Josic. Okay. Igor doesn't seem to be on the system, but let me read his question out. How do you see the position of satellite telecom operators? Will they be partners, competition, or both to existing modern telecom operators? And this, I think, was related to some other questions about what the added value of satellite was, and the links to maybe a single standard. So I think we could take all of those as our first question. So I invite panelists to open up to answer that.
So Barry, I don't really see this any different than what we see today in the terrestrial world, where we see roaming agreements, partner agreements, what I call the the Wi-Fi network integrations with cellular networks as well. I very much see this as a commercial negotiation where potentially a NTN operator and a TN operator will agree to provide coverage and seamless mobility in the regions they feel that there's benefit. Equally, there will be opportunities for each of those operators to work independently or as a group as well. So from my perspective, I think what you'll start to see certainly moving forward as we start to see the new generation of NTNs and the current generation of NTN being offered is those commercial agreements and roaming capabilities. Once we start to see the standardization and integration occurring across those networks.
Yeah, I've just had a note to say that Q&A is text only. The attendees are not on a microphone, so I'm not sure how we can do this. Is it a question that we answer on the text?
No, I think we can answer vocally, Barry. I just don't think that the participants can talk back to us.
Sorry?
I think that participants can hear us,
but
I don't think that they can talk back to us.
Okay, fine. So we can keep this question open then, and if any of the other panelists would like to give an answer on the situation as far as the business is concerned, and satellite and terrestrial operators, etc., and how they will integrate and combine in the future. Anybody else like
Yeah, sure. Thank you, Barry. Just to confirm and a complete agreement with what Kieran just said, and perhaps go back to my talk as well. We see this as a win-win opportunity for terrestrial and non-terrestrial operators. The idea of complementing each other and devising these new business models that Kieran was alluding to is just extending current terrestrial operator markets and also equally providing opportunity for the non-terrestrial network or the satellite operators market. As we see moving from 5G to 6G, the network architecture will drive new business models as well. So it's not unforeseen, for example, unforeseeable that in the future space 3D network that Tomaso was alluding to, is we will have a G0B on the ground, part of terrestrial network. There will be a G0B in space managed by either the terrestrial or the non-terrestrial network operator, but part of the same network. So that will allow the evolving flexibility of business model to evolve. But I guess I want to restate what I said from the outset. This is a win-win opportunity both for the terrestrial and the non-terrestrial in order to achieve the common goal, which is the ubiquitous connectivity. So it's expanding the market rather than creating competition among themselves.
Thank you. Anybody else, or shall we move on?
I would just add, yes, definitely there will be a completely change of, well, there could be a change of business model depending on the type of system. For instance, if you look at the initiatives that are, launching or considering to launch some satellite in order to provide direct access to handset. They are not necessarily all driven by satellite operators, but probably they will result from cooperation between mobile network operators and satellite operators. Now, for each of the value chain associated to the different satellite system concept, probably there will be a different, maybe a role to be adjusted between MNOs and satellite operators. So even for backhaul, we know that MNOs are working with other operators than satellites. So MNOs are working with tower operators. The same could apply in this new integrated value chain.
Okay.
And I wanted to take advantage to correct a little bit the roadmap that you initially exposed starting. We see that commercial backhaul solutions will probably be available in 2022. And we see also that the solutions targeting smartphones will emerge and will start to be operational by mid this decade. So 2024, 2025, at least we see that from an industry point of view. So I just wanted to clarify that.
That's very optimistic, and I hope you're correct, Nicolas. So thank you. And any more on that one, or can we move on? There was.
I wanted, if I may, I wanted just to add some reflections on this concept of a multi-operating the system. That this goes pretty much in line with the concept of a unification that Nicolas clearly exposed in his slides. And of course, this will introduce some important technological changes in relation to network management and security. And in this, certainly both industry, academia, standardization, and so on will have to closely work together in order to come up with possibly new concepts, because what has been done so far probably is not let's say, able to tackle with this new kind of vision.
Okay, so thanks. Let me move on to, well, I guess there was an associated question about does appreciate the integration. The comment was of SATCOM and terrestrial networks. Will it not be good for a SATCOM industry to go for a single global standard like 3GPP? I think maybe Nicolas, you might want to comment, but I think that's exactly what we're doing, isn't it?
Yes, indeed. By working with 3GPP, we're not facilitating the integration and the true integration. We're not talking about interoperability, we're talking about integration between satellite and the 5G system. But also, it will probably help to define a global standard for the SATCOM, which the users are calling for. They are calling for a global standard, even for the satellite systems. Now, the question is, and that was raised in many questions in the Q&A, is how to migrate from a situation where you have very proprietary technology in the satellite communication environment to a global standard. This is the challenge. There are different ways to achieve that, but this is the main question that are being faced by all the satellite community, and it's the same question that was faced by the public safety communication sector. So I think we should look at what the other sectors have been doing, and that could be a source of inspiration for the satellite community sector, communication sector, to achieve this migration to a global standard.
Okay,
thank you.
Thank you for that. I'd like to move on to some other questions which surround the spectrum, and a question to be that was posed about, as we move forward, how we're going to share the spectrum between terrestrial and satellite in this integrated environment. So who would like to take that one on? Maybe Antonio?
Yeah, sure. Thank you, Barry. Maybe I'll give it a go. Yeah, spectrum is the bread and butter for telecommunications, both satellite and terrestrial. So it's the essential element of which the technology and the business is built upon. With the converging between satellite and terrestrial network and the new allocation of 5G frequencies, the adjacency of satellite, the previously well-defined and segregated satellite frequency bands, fixed satellite spectrum and mobile satellite systems and terrestrial system was very clear. Now it's getting much more blurred. And we, on one end, on the other end, the integration of different networks that we are advocating and the unification and hybridization of terminals also call for some of this frequency band to be handled more in a more flexible, agile way. So I think, yes, it's a big issue, and there are, we at ESA, we have a number of activities in place. First of all, we think we need some sort of global spectrum monitoring system which allows to understand dynamically who's using what and what kind of use spectrum, both satellite and terrestrial, is being made. And then based on that, a more active and agile spectrum management system, which allows to better understand the interoperability of utilizing spectrum from both terrestrial and satellite systems in adjacent bands. Some of the development I was advocating, in fact, is developing some sort of, perhaps we need some sort of emulation or digital twin or whatever you want to call it, in order to understand the implications of having different optimized spectrum management techniques, which allows the cooperation or the coexistence of satellite terrestrial systems under specific conditions. So I don't have a magic answer, but this is one of the big areas of research that and convergence, where satellite and terrestrial need to get together in order to better define, characterize, understand, perhaps map, and then devise a new dynamic and flexible spectrum management techniques, which allows the coexistence in some form of terrestrial and satellite, and also the coexistence of multiple satellite systems utilizing spectrum in different orbits, for example. So it's a very complex area, and I'm sure all the other panelists will have their view as well, but it's certainly a key, essential element to tackle and to solve in this converged roadmap towards 6G.
Thank you, Antonio. Anybody like to come in? No? Okay, I think this is, I agree with you, this is an important issue, because as we move above Ka band, there's no exclusive bands for satellite, so we will have to engage with the other communities to equitably share the spectrum. And I think you're right, this is going to be done more on a cognitive basis in the future. Could I move then on to another question, which I saw, which actually concerned complexity and the fact that these systems are getting more complex. There's a question from Maria Guta. Does the satellite industry consider the implementation of smarter satellite nodes of the envisaged 3D NTN? What are the most important elements to be developed here? And how are we addressing the global competition on this domain? And if we can link that to, you know, as we increase complexity, is this going to increase cost? Because essentially what users are interested in is reducing the cost per bit. So would anybody like to take up the complexity issue?
I can try if you want. It's indeed it's I exposed the economical challenge associated. For instance, let's take the smartphone use case and constellation, and we're talking about, you know, few dollars gigabyte delivery cost via satellite in order to be competitive enough and make a sustainable and economical viable system. And this is possible to choose that. Now, if you add more and more complexity on board the satellite, then obviously you may go a little bit off track. Well, at least today. So there could be, but there are other use cases, not necessarily related to the consumer market expectation. And there are some vertical market that could accommodate a higher delivery cost. And therefore, it's a trade-off of what kind of, yes, you can add some complexity on the satellite, definitely, but maybe what kind of market segments we're going to address, you know, with this additional complexity. So it's a very interesting trade-off, and that we are currently doing. Yes.
There were one or two questions surrounding the various LEO constellations that are coming on, and whether there were challenges in timing and for those LEO constellations and other issues that those constellations might play in 6G. Would anyone like to address those LEO constellation issues? Are they fundamental to 6G, or do they have issues, and what challenges? Tomaso?
Let's say that, as I also presented in one of my slides, LEO satellites or even the very low Earth orbit satellites that are quite popular nowadays, at least in papers and so on, have certainly the merit of further decreasing the possible latency. Because I've seen also some questions in the chat claiming on the limits that satellite may have with respect to the latency requirements. That is a kind of classical argument against the advantages that may offer satellite. LEO satellite, we all know that provides much lower latency in comparison to geostationary satellites. And this can be certainly a role that this LEO satellite can play in this beyond 5G and therefore in the 6G phase. Of course, LEO satellite intrinsically bring also other challenges from a technological standpoint because of the handover as well as other aspects. And nevertheless, coming back to the original point, that is to have a 3D satellite NTN architecture. This means that multiple assets might be interconnected one with another, and as such is not just about LEO satellite, but might be also about integrating other space assets like airborne apps and although maybe not specifically NTN included, there are drones. So that in the end, the ecosystem that we are envisioning is pretty rich. Certainly LEO satellite should be there, but it's not just about LEO satellites in my view.
Anybody else on LEO satellites?
Yeah, if I may, perhaps the question was also about whether the current existing constellation will be able to support 5G, 6G, and what are the implications if they don't. Obviously, it's a time issue, and perhaps moving in the future, as perhaps Maria mentioned in some of the question before, was about the smart nodes. So I think the flexibility of space segment as a service is something that requires a high degree of reconfigurability, and in order to support 5G, 6G network in a fully integrated way, perhaps we need satellite of the future, which are capable of having more processing power. Existing satellite, however, can play a role in the current 5G deployment, certainly as backhaul, and also, as we've seen more recently, if they are transparent satellites, even LEO satellites, can support non-terrestrial network interfaces. And we have made some of the experiments over GLEO satellites where NTN can be supported today. So there is a trade-off between what the current constellations can do and what future element of constellations will be able to do in the future, where one or more satellite could be reconfigured, for example, to be part of an existing 5G network, just to extend the 3D space capability in on board. So I guess the answer is yes, current satellites, current LEO constellation will be able to play a role in 5G to have a fully merged, integrated space network that requires new, more intelligent space capability on board the payloads.
Thank you, Antonio. We're coming towards the end. I wonder if I could just have a final question to you all with a one-word answer, if possible. What do you consider to be the key technology in moving from 5G to 6G in the satellite domain? Start with Tomaso. Tomaso,
yeah, just in one word, it's very difficult. Yeah, from my point of view, a possible word would be softwareization.
Softwareization, thank you. Antonio?
Yeah, intelligent payload, softwareization, but also integrated user terminal antennas, miniaturized user terminal antennas.
Okay, Kieran?
I'd use the word silicon.
Silicon.
The way that we see ASIC and FPGA developing for the space industry.
Okay, and finally, Nicolas?
I would say maybe artificial intelligence to allow this very smart combination of the different components. So.
Okay, thank you very much. I think we're just about out of time, so it just remains for me to thank the panelists very much for their presentations. I hope we've given you a picture of how satellites will play a part in 6G in the future, and some of the challenges that which we have in going forward. Can I thank all the questions, and my apologies to those that we haven't answered specifically. So thank you very much for attending this session, and we're happy to answer any questions, I'm sure, outside the session as well. Thank you, everybody.